I'm seeing people still join in on Instagram. Welcome. I love that. But Instagram is not always great for today's session. So if you want to switch over to YouTube, get the widescreen view, you can see all the notes and the code I have up on the screen. But thanks for being here. Let me go ahead and look at the chat. I see a couple of different things I wanna address. Alan says, Bootstrap not to be confused with front-end CSS framework. Yeah, thanks for pointing that out. Thanks for pointing that out, Alan. He's right. Bootstrap is a concept in the chapter that we're looking at today, and it also happens to be the name of a front-end GUI HTML framework that's available by, I believe that's put out by Twitter. I think Twitter was the originators of that. And by the way, I love Bootstrap. It's a great framework if you guys haven't looked at it. For data scientists, Bootstrap is a great framework to learn because it's so easy to make something look good. I cannot tell you how many presentations I've done using a Bootstrap front end because I can put it together so quickly. So yeah, thanks for pointing that out, Alan. And as a side note, if you guys want to look at Bootstrap, it's a fun framework to work with. Ravindram, we're going to come back to questions at the end, okay? Okay, but I think I've covered this slide enough. Right, but I hope that you guys are kind of starting to get it here, right? We're just talking about training an algorithm. This is the training part of it. Whenever you hear those terms, resampling, cross-validation, bootstrapping, that's what we're talking about. We're talking about building up an algorithm. All right, let's go to the next slide here. Oh, where am I? Sorry. So they give you two ways to do this, right? Cross-validation is the first one. And I'm going to put this up on the screen here. And the reason I'm putting this up here is because, well, let me take a step back here. To me, this is one of my favorite questions to ask in an interview. I ask this in just about every interview that I run. So if you want to work for me, I will ask you, what is cross-validation? Can you please tell me what is cross-validation and why does it exist? Now, I think all of you can kind of guess at the model answer because I basically just gave it to you, right? In what we've been talking so far. That's the model answer for me. The reason I'm putting these definitions up there is because I want you to see how similar they are to what we've already been talking. The problem that I've had throughout the years is that when I ask about cross-validation, and by the way, I'm not going to pick on anybody, but I saw this problem in today's chat and also on the meta conversation. The problem with that question is that people inevitably give me the answer for k-folds validation. So I want you to see what the authors wrote here because it fits the same approach that we used before, right? Because you can see here, divide the available set of observations, the fitted model is used to predict, and the responses for the observations in the validation set, right? So it's basically the same thing, right? Here's the data, try it against the model, what are the metrics? But people usually end up giving me the answer for k-folds cross-validation. So what I want you to understand is that cross-validation, the model answer for cross-validation is that it's the way the model learns. It's the way the model understands and trains itself. K-folds is how it chooses the samples from the data. That's it. That's all. That's all the difference is, but it's a really vital difference. Because like I said, people usually end up giving me the k-folds answer instead of the cross-validation answer. So I want you to understand that it's kind of like the umbrella. Well, the bigger umbrella is resampling. The next level down is cross-validation. And then below that, or a component of cross-validation, let's say, is the k-fold side. Because people also kind of forget that there's still also leave one out cross-validation, right? And just nobody really mentions it, right? That is a valid way of doing it, right? So I kind of want you guys to remember this because this is kind of where you would start to separate yourself from not just in interviews, but in your own data science practice, right? Because we're not trying to pass interviews here, right? We're trying to be professional data scientists. And I want you to kind of have that separation in your mind, because this is sorely lacking out there. So if you can do this, you will distinguish yourself among your peers, right? So I want you to think about the answers that you guys have given me and realize that it's not about the size of your data set. It's not about overfitting. It's not about all these other things. It's just about training my model and how I'm choosing the items from my training set, right? Like the process, the theory that I'm using for choosing from my data set, right? Because leave one out cross-validation is significantly different than K-folds, but it's still a way to learn, right? You can still learn via leave one out. And again, I also want to point out that this is one of those things that you're really not always explicitly choosing in your code. You're not always saying, well, I want you to do cross-validation and I want you to do it via leave one out, or and it has to be via K-fold, right? So this is more about understanding the theory and the process, but in the real world, you're just going to be using like a fit function to help you come up with a model. The libraries kind of compress all of that for you into a fit method, a fit function, right? All right, so back to participation. I have a third bullet on here. And the authors talk about this. Remember in the previous classes, we've talked about qualitative and quantitative problems. Oh man, shoot. I'm sorry, guys. I have an error in here. It's not quantitative, it's qualitative for this question. Quantitative is when you have like a specific value or specific number you can give, right? Whereas quantitative is more about like categories or, you know, some sort of a classification, right? A lot of you have attended a previous session, so I'm sure most of you understand this, right? So, what about qualitative problems? Those classification problems where we're getting like a classification or a category answer. How do we have to treat those differently during resampling? So have a minute to think about that and let me know in the chat. What about qualitative problems? How are we going to go about those? The authors tell you, but they don't tell you. But, you know, you guys are all smart. You know, I see this chat. You guys are a really smart chat. What are we going to do about those? What are we going to do about qualitative problems? Let me know what you think. I'm going to be reading the chat here, but you guys tell me what's going on. Give you guys a minute to think about that. Again, reminder, if you're on Instagram, love Instagram, but these classes are just better on YouTube or Twitch. Okay, Ravindran is offering up the first answer, and he says confusion matrix. Give me a little bit more information there, Ravindran. What exactly do you mean, please? Sarvesh, welcome. I don't think I've seen you before, Sarvesh, so welcome to the class. We use encoding to convert it into a quantitative problem. Okay, Sarvesh, I think you're on the right track. Take what you just wrote and take it just one step further. Take it one step further. But you guys are welcome to write about qualitative problems. How are we handling those? The authors, I think if I remember right, it's like a little subsection in one of their chapter sections.